Hello. So I'm Tom. This is the obligatory slide about me. So I work for a company called Zesty. That's a little bit confusing because there are two Zestys, and the Zesty here in London does dentistry, but I work for the Zesty in San Francisco, which does food delivery. But I'll tell you a bit more about that later. So it's the other Zesty. So I live in Oxford, and I'm one of the organisers of LRUG. So if there's anyone here who fancies a trip to Oxford to give a talk at a rather smaller meetup, then do come and talk to me afterwards. We are looking for people. And I also do some maths tutoring. So I tutor the undergraduate maths course at Oriel College, which is part of the university there. So that's me. So this is a question that's kind of been top of my mind for the last week or so, and it's something that I still haven't completely nailed down. But I think what I should be able to tell you a bit about is what this talk is not. And top of that list is this talk is not particularly well organized. But beyond that, it's not really like a selling talk. Like, I'm not really trying to sell you any of the techniques that we've used. It's more just like telling you some of the problems we've faced and some of the solutions we came up with, and more than that, like our thought process of how we got there. So I'm hoping that there are going to be people in the room who are facing similar problems to the ones we've faced. And this can be kind of a starting point to have like a discussion around them. And I'd be interested to hear how other people have gone around solving these things. And I'm also happy to elaborate more on what I'm going to talk about in this talk. So let me start off by explaining a little bit more about kind of the background to this talk. And the background to this talk is Zesty. Zesty, the catering company in San Francisco, not Zesty, the dentistry company in the UK. So Zesty does catering for companies. So what that means is we work with companies, mostly tech companies, who give their employees lunch and dinner. And we have account managers who talk to them and figure out what sort of food they want. We then order that food from a restaurant. We pick up the food, we deliver it, and for our larger clients, we serve it in a setup that looks like this. So I think we're now the leading office catering company in San Francisco. We've got about 80 employees, of which 15 of are developers. So this story really starts kind of about a year ago. So I joined Zesty like a year and a half, almost 2 years ago. Or is it 2.5? A while ago before that. But then just over a year ago, we got into YC. And at the time I joined the company, it was like an app like Just Eat or something where you could order, or in fact, like Deliveroo, where you could order from local restaurants and like you'd order individually and your food would turn up. And we got into YC and we pivoted to doing office catering. And during the like 10 weeks of YC, we grew 30% week on week, which is kind of terrifying when you think about it. It means you go from doing 0 office catering to serving like, I guess it was like 10, 15 meals every single lunchtime. And while that was great for the business and like we did really well and raised a good round coming out of YC, it was kind of terrifying to being a developer, of which there were only 2. And we got to that point at the end of YC, we just raised a load of money, we were expanding our team, and basically the code base was just, it was interesting. It had all been just piled on top of like what used to be an app, and all this stuff had just been chucked in. It was one big Rails app. And so what this talk is about is like about the problems that arose from that like very quick growth, and how we dealt with the next round of problems, which was how to like scale the business, and which involved like solving a lot of like hard sort of logistics type problems, and how we put that on top of a base of something that isn't the sort of thing you'd want to build upon. So it's really about scaling issues in a company and with a Rails code base. And when people talk about Rails scaling and scaling issues, normally what people are talking about is performance. So the idea that Rails doesn't scale becomes very hard. Like I guess the typical example here is something like Twitter. They started off as Ruby on Rails, they got massively popular, and then they had to switch away to, I think it was Scala or something. But that isn't actually what I'm talking about here. There's another side to scaling, and that is the idea of complexity. And I guess it's something maybe peculiar to our business, or it's possibly like common in other businesses, that performance really wasn't our problem because we only had about 50 users. Our 50 users were our internal account managers and people managing our drivers. There wasn't a lot of load on our servers, but our real problem was that our business did a lot of things, and that was so coming back to Joe's talk, that was kind of inherently complex. There was a lot of stuff that was just hard to manage. We were doing things from ordering automatically from restaurants to we had a couple of driver apps to tell us where our drivers were to go. We did live tracking of drivers. We had to schedule them all in advance. We had to bill our customers. There was just a load of, we did a load of nutrition analysis. There's all these things, all these different areas that had grown up very quickly and were quite different. And it was just very hard to understand what was going on. And so this complexity thing is so we've got a picture of a knot there. And has anyone seen the Rich Hickey talk, Simple Made Easy? Okay. You should all go and watch it. It's really good. So Rich Hickey is the guy who does Closure and an interesting database called Datomic. But anyway, that's separate. Anyway, so he gave this amazing talk, Simple Made Easy, and it's talking about managing complexity in code and how you do that. And he pointed out that actually complexity comes from the word complect, which means to intertwine things. And so a knot, things are complex if they're knotted, they're very hard to kind of understand. And I guess what I'm talking about is having a code base which somehow breaks the level of what humans can understand easily and how you sort of do that. And I wanted to use a topical analogy, so I decided I'd use football. So this isn't the football you'd recognize today. This is football in the medieval ages. And there weren't really any rules. The whole village just turned up. There was a ball. There's a guy on a horse as well. I don't know what he's doing. But this is no doubt a game that would have been very difficult to understand, and almost certainly wouldn't have televised well. While I was looking into this, I found this amazing quote. But these matches did not always end in a civilized manner. With limited rules and no referees at the time, the pitches became violent. It was acceptable to beat or punch opposing teams. And anyway, I read all this, and I was it's interesting that football seems to have come full circle in many ways, but now this sort of thing happens outside the stadium rather than inside it. But anyway, that wasn't the point. The point is that this is complicated and it would be difficult to understand, and that's not what the modern game looks like. The modern game is comparatively simple. There are very well-defined rules, and there are a limited number of players on the pitch. They will have positions, and there are kind of rules about what people can do, the rules of the game are obvious, but there's also kind of the structural rules. The idea that the strikers try to put the ball in the goal and the goalie tries to stop the ball going in their own goal. And I'm not really a big football fan, but I've got the essentials, I think. But the idea is about how players move through the pitch, how the ball progresses up the pitch. There's a structure to it, which makes it easy for humans to play. And to work together, and also to understand and appreciate. You can see the patterns on the pitch, and you can kind of see what they're trying to do. And so it's also interesting that there are now only 10, 11 players on the pitch in any one team. And there's kind of one of the reasons I was interested in like this level of what humans can understand is there seems to be this sort of number that you can understand in a system where objects interact with each other. There's like this number, and I don't know what it is, but it's more than 10 and it's less than 30, probably. There's just like this sweet spot of numbers that it's kind of possible to understand. And like if you think about these systems, and in fact, it's also affected by how these objects interact with each other. Because if you've got like objects in a system, and you think of their interactions, the interactions scale with the square of the numbers. So like if you have 10 things in your system, you have about 100 interactions, whereas if you have 20, you have 400 interactions, roughly. And so it's kind of important, like, not only how many things there are, but how they talk to each other and how they're allowed to talk to each other, and is it obvious what the patterns of like one thing talking to another thing is? So to actually come back, this is about code, this talk, and it is about refactoring a Rails engine. So this is like the problem we had at the time. So this is just like a little section of our models folder in our Rails app. Just like a random little section. And it's possible that this wasn't very well organized, and I'll talk about that a little bit more. But there's a fundamental like problem here, I think, in that some of these things are not like the other things. So you don't need to understand what any of these things are. But the important thing is like 2 of these objects are fundamental to our system. Like we've got the catering client and the catering order. And those are kind of like top level concepts that anyone interacting with the system needs to know about. But they're in this folder, and they're all in like a thing with like these other things, which are just details. So the catering order template is something that's just used to create catering orders. Catering nutrition requirement, I don't even know what that is. Close period, who knows what that's a close period for? Like there are all these things which are like basically just details, but they've been given the same like status as these really important top level concepts, like central concepts. To our organization. And because of this, it was very hard to understand what our code base did. Like, I think at this point we had around 80 models. And that's not in itself bad. It's just, you can't understand 80 things if you don't know how they're meant to interact with each other. And there's only so much you can get from like looking at the names, understanding what they're meant to do. And so, again, like this is very, very interesting because this is like probably extraneous or irrelevant load on your brain. Like there are some things that you have to understand, like the intrinsic load of like we're in a business which is kind of doing a lot of things and they're quite complicated. And then there's like this other stuff, like all this noise that we just put in around it. And so what this talk is really about is like how we dealt with this. Now the first thing we thought about when we were tackling this problem was microservices. So microservices, especially a year and a bit ago, were like very like in vogue. The idea there is that you take your application and you split it into like several different applications, each one of which does a sort of well-defined problem and is easy and simple to understand on its own. And this has a number of advantages. So this is what I think there are a load of things like can't remember. Netflix is a prime example of how they get like really good performance and scale through microservices. And these microservices are deployable and scalable independently, and that's important, especially if performance is one of your problems. You know, like if you've got one bit of your app that's being really hammered, you can divert resources just to that bit of your app. You can spin up more things. You can put them on bigger dynos, whatever. Whereas, of course, if you're deploying your code base as a single code base, you don't have that sort of control over those sorts of things. And you also, as a development team, you get clear ownership and responsibilities. You've got your app. You know what it has to do. You're responsible for that. Other people, you know, like it's a very natural way to organize your teams around different areas. So that was the first thing we thought about. And obviously, there are a lot of disadvantages to microservices as well. So the top one, in my mind, is that when you're doing something like a microservice architecture, a lot of the hard development decisions come down to defining the interface between your components. Like, it's all very well having one simple component that does a single job, but understanding like how other things are going to talk to it and what that job is going to be, actually that's like the majority of the hard decisions you have to make. And that really sucks because those decisions are expensive to change. Like, you've got two teams working on the same thing. One team's like, actually, I don't have the information I need, so now I've got to go and talk to another team or another app, and we've got to deploy a change at the same time between the two of them, and it just gets it gets complicated, I guess. The other thing is that the deployments are actually more complicated. I mean, it's all very well to be able to deploy each app independently, but how do I know that like the version that I'm deploying of this app is going to talk to the right version of this app, and how do I make sure I don't make mistakes there? That's really the next point, actually. What I was meant to say here was that, sorry, this is the disorganization. What I was meant to say here was like, you also got to deal with the problems of what happens if one app goes down. You know, like what happens if I'm trying to talk to someone and they just like crash and go to sleep? You then have to have like these more complicated modes of conversation between these two things. And coming back to the thing I said before, is testing is harder. Like, how do I make sure that these apps like talk to each other and I don't break them? And you can do things like you can do contract-driven development, where I sort of say like, this is the language I'm going to talk to you. Here, I put it in a file. You take that file. You check you understand that language. But then every time I want to change that language, I have to kind of retest everyone my thing talks to, and it just gets very tough. And we realized that because our problem wasn't performance, we didn't really have to do this. Our problem was complexity rather than performance. And we didn't want to deal with this stuff, and quite honestly, I don't think we had the expertise to do it. Like, we could have spent a lot of time figuring out how to really do microservice architecture, but we were in the position where we really needed to just keep building stuff so that we would be able to serve the meals we were committed to the next week. It was sort of like that sort of week-to-week kind of development stuff. So then we came across this blog post. And if you take nothing else away from this talk, just go and read this blog post. It basically explains a lot of the stuff, probably in a far better way than I'm explaining it now. It's a blog post by TaskRabbit. I don't know if people have come across them as a startup, but they you can get someone to come and nail some stuff into your wall and stuff. But anyway, it described this approach with like Rails engines, which is basically what I'm going to talk about next. So I'm not going to talk about that very much at this point. But yeah, so let me talk a little bit about actually going back to basics and sort of say what a Rails engine is. Who's actually used Rails engines before? Who's created a Rails engine before? Okay, that's pretty good. So this is the like page in the Rails guide about Rails engines, and it has this thing: engines can be considered miniature applications that provide functionality to their host applications. Now, that might mean something to you, or it might not. But let me tell you actually how you create an engine and what happens. So you create an engine with this command: Rails plugin new my engine -- mountable, and it's the -- mountable bit that makes it into an engine. So what an engine is it's like a little slice of a Rails app. It's like a mini copy of a Rails app, so you get everything. You get like the controllers, models, views, and it's all packaged up into a gem. And the typical workflow with engines is you create an engine, you package it as a gem, and then you include it into your app. And I guess the canonical example of an engine in Rails is Devise. Who here has used Devise? most people. So like it does passwords and stuff. And devise gives you, when you include devise into your application, you get the roots, you get controllers, you get models. Everything comes together. So this is a like normal workflow, but this is actually not what we chose to do, and this is not what like TaskRabbit chose to do. So what we actually did is we ended up with a setup like this. So this is our top-level Rails app, and you can see up the top we've got our app folder, and I've like just collapsed that. But then we've got this folder called apps, and in the apps folder we have a load of engines. So these are kind of like the high-level engines in our system that describe the different areas of things we do. And the way we did this, like you can find out more about, I'll leave a link about how to actually do this. So I'm just going to go over it in very quick detail. So basically what we do is we generate the new engine using that Rails generate new plugin mountable stuff. And then we just delete all the stuff we don't want. So we delete the stuff that makes it a gem. We delete the stuff that makes it its own Rails app. There's probably a nice way of doing this. I'm pretty sure you can set up a Rails generator, but we do it so seldom that we haven't. So we just like go in and we delete all the files we don't want. And then we just copy it into our apps folder. And then we plumb it into our application. Sorry, you probably can't read that. So we have this bit in application.rb. We add the engine to the load paths. And then because it's this mountable engine with roots, you can also mount it in your like roots.rb, which like pulls in the roots into your application. So we end up with this apps folder with all these like mini Rails apps nested inside it. So the question is like, does this solve the problems that we were setting out to solve? And in some ways, the answer is yes. You know, like we've now got these higher level things that you can see in the apps folder, like the different areas of like our domain, and like they're all like top level concepts like routing and I think it's called scheduling and like orders and things like that. They all like belong together. There's no like distraction there, which is good. But in another way, it hasn't. Like, because really, all this is doing is namespacing our code and moving it around. So we've now got everything related to like scheduling in a Rails app called scheduling, and it's all under a namespace scheduling, and then the name of the models. But it could be just as complex as before. Like, there's nothing to stop you just like separating them out, and then all these things, we've just got more objects, you can't see them, and they could all still be talking to each other. You've still got exactly the same thing. So like, we've got some sort of semblance of order, but there's still the rules are still unclear. Like, still anyone can play with anyone. Like, it could be mayhem under the covers. So it's kind of like a superficial, it's a definite improvement to the code base, but in some way it's like giving you this like superficial semblance of order. And so we augmented this with a couple of rules. And these aren't rules that we're like, you can enforce in Rails. But they're rules we like, I guess they're more like conventions that we introduced about how the different engines can talk to one another and what you're allowed to do when you're like interacting with an engine. And the first rule was that engines communicate via their top-level interfaces. Now, that probably doesn't make much sense, so I'm going to give you an actual example. So this is what our operation system looks like. So what this does is this like basically does most of our fulfillment. So we have the model at the top is the catering order. I ought to also say this is like an ongoing migration, and so like some of them are still just we still have an app folder and still we have some models in there, but we're gradually kind of splitting things out. So the catering order is still in the old system. it's almost like a form object now, in that we display it to the account manager, and they put information into it, and it gets saved, and then that information gets pushed into all these different systems. So the first place it gets pushed is into the food ordering system. Now the food ordering system takes a look at what the items on it are, and figures out like which food, well, it basically figures out the order that it should send to the restaurant. And it also does that in a clever way, so that if I change my order, it can figure out, do I need to send an update to that restaurant, or do I need to cancel the original restaurant and send a brand new order to a new restaurant? So it like does all that, like that sort of logic. And it also creates some jobs, because like when you've created the order, you need someone to go and pick it up. And these jobs go into our ops system. And the same thing, we have like this on-call system. So if somebody like calls out, like, I can't do my job today, we've got some workers who are on on-call jobs, and the on-call system also pushes these, like, they're actually called pre-jobs, in probably some fairly dodgy naming, but like pre-jobs because they're before they come jobs. So like they like encapsulate the requirement of a job. So it like has like, I need someone to be in this place between these two times, and then in this place between these two times, and they need to have the capacity to pick up this thing and then carry it in their car and all that sort of stuff. We also have trials. So like we train up our workers. So like trials create jobs as well. And in the future, we'll also create jobs from our inventory system. So like someone needs to pick this thing up, and all these things pool together into our ops system, which then calls out to the scheduling system, which then goes back to ops. Like the scheduling is just like this kind of auxiliary system, and then ops transmits some information back to the systems to tell them when it's scheduled their jobs. So that was like, sorry, I probably gave too much detail there, but this is what the high-level ops module looks like. So in the ops engine, it has a lib folder, and it just defines this high-level interface. And you can see the high-level interface is very small. There are only a few things. You can register an availability, which is a worker is available. You can register some pre-jobs. So that's like a group of things we need to be done. And then you can fetch the plan, which is what happens at the end. That's like the callback method, like these are all these, where these things are going. And the system calls it like this. So this is the like first rule of engines. Like you only go through the top level interface. I don't call any of the stuff inside the engine. I'm not even allowed to know what's in there. All I know, external to the engine, is what it defines in its top level interface. And this is kind of nice in some ways, because that rule is encouraged, heavily encouraged, but it's not impossible to break. And this is exactly going back to like the microservices stuff. Going back to the microservices, it's impossible to break the rules of microservices. If the data you want is in a separate app somewhere, there's no way you can cheat and get it. Whereas this is great because you can bend the rules if you have to. Like if you find out you just can't get it through the top level interface, but you really need it, then you can just reach in and like touch the things you're not meant to touch and like pull it out, and then afterwards like you can fix the top level interface to do it. So it's a way of discovering what the top level interface should do in a way that's far cheaper than like creating these microservices. And the second rule we had, which is kind of very related to the first rule, it might even just be the first rule in a different form, is that each engine owns its own data. So what that meant for us is that we didn't split them out into separate databases. We just prefixed all of the tables from one engine with the name of that engine, and then just like, so we could like consider them as separate parts of the database. And I'll give another quick example here. This is our selections engine. You almost certainly can't read that because I can't read it. I couldn't manage to get it a bit. But anyway, the point is that this stuff in here is really complicated. A selection is what we use to model like the things that were ordered. So like your selection is your shopping basket, basically. It has items, each item has a quantity and a dish that was ordered, and then there's a load of other stuff. But the reason this is so complicated is that we need to do things like, we need to have recurring selections, and if you have a recurring selection, its price might change over time. Or we need to display things about the selection, and maybe the image has changed or the name has changed. Like, it's basically thinking about how to do updates and how to like keep the essence of like, these are the dishes we ordered and this is the current version of them at any point in time. We also might need to, it's also not enough to know this is the price at this point in time. We might need to send the order for 2 weeks' time, and it all gets really complicated. So this is why this is like so horrendous. But this is the way you interact with it through the system, through the top-level interface. And you're not, so lots of things in our system store a selection ID, which is an integer which represents the selection that you're talking about. And the selections engine will provide you this selection, and it can also provide you some extra information about it, like its pricing and stuff at a given time and all that sort of stuff. But even though all these different tables, all these different parts of the system hold basically the foreign key of this table, we don't allow them to hold foreign key relationships, and we don't allow them to pull that thing out automatically. And that's annoying. That is annoying. Like, when you've got a meal, you just want to find its selection, and you have to go through this. But it's also like essential, and it's flexible. Like, this really paid off recently when we decided to refactor the selections engine. Like, the only guarantee that it's making to the system is that it'll give you an integer, and when you ask that integer, it'll give you back the selection that you wanted. And so we wanted to migrate from like an old style selection to a new style selection, and we were able to do that because there was no foreign key relationship. We just swapped out all the integers. And we were even able to like do it continuously by taking the old ones and swapping them negative, and then introducing the new ones, and then like swapping the old ones positive, and then just like waiting until we got rid of all the negative. It was great because we'd like we'd introduced this rule which, though it made things more difficult for us, it made things more easier in the long run. So those are kind of two examples of like the two rules that we're using. So one of the consequences of this, which is kind of, I guess it's useful to think about like what the trade-offs we're making here, because like this is a good trade-off in a big complicated system. For a part of it, you wouldn't want to do this in a normal Rails app. If it was just a small like simple Rails app, you'd never want to like have an engine and not do foreign key relationships and not use Rails stuff to pull out those models more easily. So the other thing that you get from this, which is a consequence of these separate each engine owning its data, is you get model fragmentation, which is also kind of like an interesting thing, and in some ways a good thing, and in other ways a bad thing. So like this catering order, which used to be one concept, and it was a bit of a problem because it was like a very overloaded concept. It basically did everything. It was a bit of a God model. Like it has like, I think to this day it still has like 400 lines and then a couple of modules that it like pulls in just for its stuff, but we're gradually separating it out. But you have this like concept of an order, and then each system understands it separately. So the meal allocation system, which is what we decide what food to serve people, it just knows about the head count, the budget, and the preferences. The scheduling system just knows about the location of the order and its time. The accounting system just knows about the price and the client. And in some ways it's horrible because you open up like all these problems, like keeping these things in sync, and that like is a very essential part of like one of the downsides of this stuff, how to keep things in sync. But it's also very interesting. So it was around this time that I realized that what we were doing actually had a name or belonged in a set of things with a name, and that thing was domain-driven design. So who's heard of domain-driven design? Yeah, so I hadn't. but now I have. But it talks about, it has a number of different parts of it. It has like this stuff about this ubiquitous language, which is like all about listening to the language that you're using. It has this stuff about entities and value objects and stuff. And it also has this stuff about preserving model integrity. And that's something, they have this phrase called bounded context. And this is like bounded context. It's this idea that you've got this one concept in your application, and different like parts of your application understand it differently. So like the accounting team don't care which dishes you ordered. All they care is about the price and which client they should charge it to. So it leaves people free to like, if you're developing in an engine, you have your understanding of what an order is, and you don't need to understand beyond that. Problems, as I say, come with like the syncing of these systems. How do you make sure that like when I change something on the order, it gets through to all the different places? But that's actually like not that hard. When that's your problem, then you figure out ways to do it. So we just have like delayed jobs that push things through to the different systems and stuff. And it's kind of also like this idea of things being able to be out of sync is actually another, I could probably do a whole talk on this separately, but it's actually like been really, really interesting thinking about like how these things kind of sync up. Like the example here is the scheduling system. I guess if you just got a data relationship to something, I guess the fundamental question is, how do you know when that thing has changed? So I've got a scheduling solution, and it had a load of pre-jobs that it depended on. And one of those things has changed, like some order somewhere. Like imagine a pre-job had an order and it had a start time. Someone goes and changes that start time. That could change the whole schedule, because I've like looked at all the jobs and how do I know that that should have changed? And this idea of having to have these events where you push updates into a system gives you a very natural place for that. I'm not having to like observe database objects. There's this like, the data comes in and then I decide. So like you push an updated order into the scheduling system, it does all the stuff to figure out if the old schedule it had is still good or if it's not, and all that sort of stuff. So it's also very interesting because we basically have come almost full circle to a microservice style architecture where you've got these different independent like parts of your code base. The data is flowing between them. But we've done that without having the complexity of managing a service-based like deployment architecture and stuff. So yeah, that's all I've got. It's now time for the pub, and I don't want to delay that any more than I have to. But I don't know, maybe we have a minute for questions, do we? Or maybe not. -1. One question. Okay, well, we could do one question if we want to have a question. But if not, like, contact me.
At the end, when you have 3 boxes, previously you said that you prefixed each section brings data.
Yeah.
You split out order. Do they all in 3 tables or 1?
3 tables. So like this model is the scheduling order, its namespace scheduling order, its table will be scheduling underscore orders, and so on.
Just one thing, now that you've done all this, can I make a suggestion? Look up CQRS-DS.
Okay.
Command query
Yes.
responsibility segregation and event sourcing.
Yeah. So I've come across those. It's kind of similar to those ideas, isn't it? It's like, yeah, I do know what that is. I've come across that. But it would be interesting. One more over there.
So it sounds like you use engines to modularize your app. Why not use modules to do it instead? So rather than having apps orders engine, you simply have app models orders, which is modularizing your code.
So we did actually sort of do that. It became sort of nicer to have the models of views and the controllers in the same place. Like there were some engines which genuinely had like all 3. Some of them don't. Some of them only have a couple. Quite a few of them have an API as well, and they have like an Ember app or something that talks just to that engine. So that is exactly what we started doing actually. but it was just like I was doing so much like context jumping between like the scheduling in the models subfolder, and it just seemed nicer to bring it all into one thing, and then it's more natural to like group it together and enforce these rules. I guess one day also, if we did want to do a service-oriented architecture, we could just take these engines out and put them somewhere else. They're like all in one place, so you can just kind of just pick them up in one go. Done. Okay. Pub time.